Okay, continuing on in 16, this will be video H. This video is going to address fixed alpha level testing. If you stay tuned for video I, we'll get to what Joe was talking about in the last video about using confidence intervals for hypothesis testing. So that's coming. But for a minute, let's look at what fixed alpha level testing, what's that? So sometimes when hypothesis testing, we need a firm answer with exactly how much evidence we need to reject the null hypothesis. Perhaps the Federal Drug Administration is approving a new drug. They're going to run a completely, or a double-blind, completely randomized experiment. And so the question here is, exactly how unusual would the results of an experiment need to be for us to conclude that the new drug is better? And a lot of times they'll want to make that decision before they run the test. So sometimes it's better to specify this before the test. And when we do that, this is called the significance level of the test, or sometimes the alpha level of the test. Or the alpha level. Alpha is the Greek letter, looks like kind of like a fish, so alpha. Some commonly accepted levels for what we consider to be unusual results. We'll set this alpha level. Often some accepted values that you'll see commonly used are an alpha level of 0.05 or 0.01. Something has to happen with a likelihood of only 5% or 1% or less to be considered rare enough to reject the null hypothesis. So if our sample data would only happen, say, 5% of the time or 1% of the time, then that would be unusual enough to reject the null hypothesis. So this will be specified ahead of time with fixed alpha level testing. Obviously, the smaller that you're making alpha, the more unusual of a result that you would need to see in order to reject the null hypothesis. I may have just given away some of these, I'm not sure. So when running a test in this manner, we'll reject the null hypothesis when our p-value is smaller than alpha. That's sort of our benchmark for what's unusual. So anything smaller than alpha is unusual enough to reject the null hypothesis. And it doesn't matter if we're running a left-tailed test, a right-tailed test, a two-tailed test. We will reject the null hypothesis if our p-value is less than alpha, just like it says up here. And again, that's sort of what you're deeming as small. If we do run a hypothesis test by setting a significance level ahead of time, so if we say reject the null hypothesis using a significance level of 5%, we would say that the data are statistically significant at the 5% level. So sometimes you'll see that language. Most times our hypothesis test problems will not specify an alpha level. This is because in the real world, most hypothesis tests are performed without a stated alpha level. But once in a while, you'll see this, so we're going to show you, what this means. But a lot of times, we won't have a fixed level of alpha. So when running tests without an alpha level, just like we've been doing, we simply look at the p-value to make our decision. We know that the smaller the p-value, that's even more evidence in favor of the alternative hypothesis. So this hasn't changed from what we've been doing. And you might even go back to your notes in lesson 16b where we drew out that p-value diagram and looked at what, the smaller that the p-value got, the more evidence in favor of the alternative. You might even put like a little sticky tab on that. That was kind of a good diagram to let you know how to interpret what to do with those different p-values. What's unusual, the smaller it is, the more unusual it is, the more evidence in favor of the alternative. Okay, so there are some advantages and disadvantages of having alpha or not. So one disadvantage of not using alpha as fixed alpha level tests is that two people can look at the same p-value And one person can come up with one conclusion, somebody else might say something else. If we ran a test and the p-value was, say, 0.052, I might say, oh, I'm going to reject the null hypothesis. That's unusual enough. And Professor Cooper-Sonnen might say, no way, I'm going to fail to reject. I didn't think that was very unusual there. So that can happen. One disadvantage of using a fixed alpha test is that a very tiny change in your sample can lead to the opposite conclusion. Knowing that p-value really helps you interpret exactly how strong of a conclusion was it. If your p-value is sort of in that gray area, you know it was kind of a close call what your decision was. Whereas if the p-value is exceptionally small, we've seen some with like 4 zeros and then a number, that was pretty strong, reject the null hypothesis. All right, so flip the page, we're going to look at an example. Let's say a statistics intern has tested a new ointment for rashes against the existing ointment. The existing ointment has worked in clinical trials for 69% of users. Oops, I've got the wrong numbers on mine. That's okay, we can make this work. The p-value for the test was 0.041. Write the appropriate hypotheses. Okay, so we're looking at the percentage of users where this ointment has worked. And so this is clearly a proportion problem. And the existing ointments worked for 69% of users. So we're going to assume that this new ointment, that it's pretty much the same as the existing. And we're looking for evidence that we want to use this new ointment. Well, why would you want to use it? You would want to use it if more people were getting relief. So this is what we're looking for evidence of. So, the null hypothesis will assume that the new ointment is just as good as the old. If they're the same, we're not going to market this new stuff. So we're looking for evidence that the new is actually better than the old. So those would be our hypotheses. All right, let's look at this p-value and draw some conclusions. So let's say your old boss was pretty easygoing, directed you to run your hypothesis test, and they give you a significance level. So 5% significance level. That tells us alpha is going to be 0.05. What conclusions will you make about the ointment, and what are the consequences? So a couple things here. When you see 5% significance level, that tells you that alpha is 0.05. And you'll recall that the p-value for this one, let me flip back, was 0.041. And so what conclusion would we make? By setting alpha, we're saying if something happens and the likelihood of it happening is smaller than 5%, that's unusual enough to say, hey, we don't believe the null hypothesis. So if you look at our p-value in this case is smaller than alpha. And so we're saying that our sample results are unusual enough that we don't believe this. Hey, we think that that new treatment's working better. And so in that case, what are the consequences? We would take this new treatment and we would market that, send that to market, and market that product. So let me write what I just sort of said here. You're comparing that p-value to alpha. So since this p-value is less than alpha, 0.05, we would reject the null hypothesis. And we would conclude the new treatment works better than the old. New ointment. And we would probably market this new product. All right, now it said your old boss, so something must have happened here. Part C, you're going to see that your old boss got fired, and we'll change things up a little bit. So, old boss got fired, don't know why. We had already collected our data from volunteers, but we hadn't published the results of our test yet. So we have a new boss. The new boss, she's pretty tough. Oops. She requires a 1% level of significance on all her tests, so she wants to see even more evidence in favor of that alternative in order to invest money in something. So what would we conclude now, and what are the consequences? Again, I'm going to compare that p-value to alpha. The p-value was 0.041. Alpha this time, she's more strict, is 0.01. This time our p-value is not smaller than alpha, right? So according to her stricter standards, our results were not unusual enough to say that we think that that new treatment, that new ointment is any better. So when your p-value is bigger than alpha, you fail to reject the null hypothesis. And we would not conclude that the new ointment's any better. We would not market this. We wouldn't send it to stores. Don't forget, this is the same data. It's, we didn't do anything differently in Part B than we did in Part C. It's just sort of what type of standard are you setting your hypothesis test to? How unusual of a result do you need to see in order to draw that conclusion? So your new boss just had stricter standards. She said anything less than 1% is unusual, whereas your previous boss had said, if it's under 5%, that's unusual enough. So last couple notes here. Remember, when you're asked to run a fixed alpha level test, there's nothing to worry about. It's not much different at all than just looking at that p-value. The big thing there is if your p-value is smaller than alpha, that's when you're going to reject the null hypothesis. So if the p-value is smaller or less than alpha, reject the null hypothesis. Okay. So in the next video, as promised, you will now look to see how confidence intervals can be used to run a hypothesis test. So stay tuned for that with Joe next. Thanks.